We have some important properties of vectors. We know that the addition is commutative. For example, if you think about vector u as, for example, 2 and 3, vector v as negative 1 and 2, u plus v is 2 minus 1, 1, and then 3 plus 2, which is 5, which is the same as v plus u. It doesn't matter. The order of addition is not important at all. Addition is associative. What's the meaning of that? It means that if you have 3 or more vectors, it doesn't matter in which order you are adding them. For example, I define another vector like vector w, which is negative 2 and negative 4. Well, u plus v plus w is equal to 1 and negative 2, which is negative 1, and 5 minus 4, which is 1, which is basically adding w and v first, then add that to u. So basically giving you the same result. You have additive identity. If you add any vector with 0 vector, so let me just bold this 0, this is 0 vector. The output is equal to v. For example, here you have vector v, negative 1 and 2, plus vector 0, which is represented by 0 and 0. It has 2 components, gives you negative 1 and 2. You have additive inverse. If I add 2 vectors which are opposite of each other, the output is going to be 0 vector. So here you have negative 1 and 2 plus its opposite, which is 1 and negative 2. It gives me a vector which has only 0 vector. Well, you can just distribute a scalar when you add 2 vectors. For example, here you have 2 vectors, you added them together. Suppose c is a scalar, which is a half. It's just a number, right? So c multiplied by the sum u plus v, which is 1 and 5, basically is a half multiplied by each of these components. You get a half and 5 over 2. If you have 2 scalars and add them together and define a scalar multiplication by any vector, is basically saying that, hey, I'm taking each one of those scalar and find a scalar multiplication for each one of these separately and then add them together. For example, c is a half and d is equal to negative 1. If I add c and d and then multiply by vector u, this basically must be the same as cu plus du. Let me show you. So a half minus 1, negative a half, times vector u, which is 2 and 3, is equal to negative 1 and negative 3 halves. This is saying that, hey, I'm multiplying u by a half, which is 1 and 3 halves, and adding that to negative u, negative 2 and negative 3. So basically I have negative 1, adding the components together, and here you have negative 3 over 2. They're basically the same. 0 times any vector gives you 0 vector. So the scalar multiplication of 0 and vector v, negative 1 and 2, is 0 times negative 1, 0 times 2. So it gives me 0 vector. Make sure you use the correct representation. If I multiply c by 0 vector, like a half multiplied by 0 and 0, this is basically having 0 times a half, which is 0, 0 times a half, which is 0, so you get 0 vector back. 1 multiplied by any vector is equal to that vector. So here you have 1 times vector v, which is negative 1 and 2. Basically, it is negative 1 and 2, gives you the same vector back. If you have 2 scalar and you're finding the scalar multiplication, you can just basically multiply those scalars together and then find the scalar multiplication. So I have a half times -1 times vector v, which is -1 and 2. You can say that, hey, I find the scalar multiplication here, and then find the second scalar multiplication. It is -1 times -1, which is 1, and then -2. Then I find the scalar multiplication here, which is basically is equal to 1/2 and -1. Or you could say, hey, I'm multiplying 1/2 and -1 first, and then do the scalar multiplication. Gives you the exact same. Here I have 1/2 and -1. As you can see, they are basically